Hi, my name is Jim Smith. This slide sequence demonstrates why three-dimensional charts are problematic. Let's say your boss tells you that the next set of graphs you produce, he'd like to see that new jazzy format, 3D. It's colorful and everyone's using it. You decide to make some mock-ups of the data just to see how the 3D would look. Here's the first one. This is a 3D column chart of overtime on 4 wards and 3 shifts. As soon as you look at this, you notice something is missing. Where's the data on overtime for the night shift for Ward 106? A green column seems to be missing. You make the blue column in the foreground transparent, and you see that the blue column in the foreground had obscured the green column in the background. So one problem with 3D charts is that sometimes some data can obscure other data. Next, you take a look at the 2 columns in the middle, the blue column and the green column. You want to determine the height of these columns, so you look at the grid lines. The green column appears slightly higher than the 50 grid line, so you assume that it's probably about 52 or 53. You check your data sheet, and it's actually 55. The blue column seems to be somewhat less than the 50 line, so maybe it's 49 or maybe even 50. You check your data sheet, and much to your surprise, it's 65, 18% higher than the green column. How can this be? You realize, of course, that the difference is that the blue column is in the foreground and the green column is in the background. If you draw a line the height of the blue column and then move it to a grid which is closer to the foreground, you'll see the value is indeed 65. But that was not readily apparent from looking at the chart. So there's 2 problems with 3D charts. First, sometimes some data obscure other data. And secondly, they require a fair amount of mental gymnastics to account for foreground-background differences in order for you to get the information that you desire. You transform the data to a 3D line, and it's even worse. The value 48 appears higher on the page than the value 50, considerably higher. And the value 23 is at about the same level as 50. Perhaps a simple line graph would be best. Here's a simple line graph of exactly the same data. Here it's readily apparent that there's a unique pattern for Ward 107, a pattern you didn't see in either of the 2 previous 3D charts. The next set of data is very simple. Resident falls on 2 long-term care units, Unit A and Unit B. It's clear that Unit A has 4 falls and Unit B has 2 falls. Since your boss wants 3D charts, what could be the harm in transforming this into a 3D graph? You transform it into a 3D chart and notice something strange. It appears now, according to the grid lines, that Unit A has 3.6 falls and Unit B 1.6 falls. Clear impossibility since these are counts of falls. You decide 3D charts are not the way to go. And when you check the literature, you find out that nearly everyone who writes books about charts and chart design has exactly the same thing to say about 3D charts. They're not very helpful and can be very confusing. Reynolds, in Presentation Zen, writes, "The 3D tool is one I could do very well without. Stripping away the extra ink that 3D charts introduce seems like a good place to start." InfoViz Wiki writes, "There is no information in the use of the third dimension, which heavily influences the pictures and very much drives the attention towards the depth of the bars and the underlying grid. As a matter of fact, they refer to the third dimension as chart junk." Finally, Few writes, 3D elements are so rarely necessary to communicate information and so difficult to design effectively that I recommend that you avoid using them altogether. For more information, go to my website, www.jamesmsmith.org. Thanks for listening.